All right, today we're going to go over tangent inverse and cotangent inverse. All right, but first let's start off with some bell work. All right, so we have the sine of 23 pi over 6. We should have recognized the fact that 23 pi over 6 is too big. So we should have said, okay, let's take that 23 pi over 6 and we're going to subtract 2 pi away from it. Well, 2 pi doesn't have the same common denominator, so in fact we're going to subtract 12 pi over 6, which will result in 11 pi over 6. Now remember, your reference angle is pi over 6, so I'm really looking for sine of pi over 6, which is going to be 1/2. And because we are in quadrant 4, we can tell that because of the 11 over 6, it is going to be a negative 1/2. All right, moving on to the arc cosine of square root of 2 over 2. Well, the arc cosine of square root of 2 over 2 is asking us, where is cosine equal to square root of 2 over 2? Well, that happens at pi over 6. That's in quadrant 1, so that fits our cosine, and so our answer is pi over 6. Arc secant tells me that I need to go through cosine to do that. So since it's arc secant, I'm going to change that to cosine inverse. In order to do that, we must do the reciprocal inside the parentheses. So rather than 2, we're going to have 1/2. Now we're asking, when is cosine equal to 1/2? Well, it's equal to 1/2 at pi over 3. All right, last one, we have cosecant inverse. That tells me to use sine inverse. And to use sine inverse, I have to take the reciprocal on the inside. So that would be negative 1 over square root of 2. We'd multiply the bottom and top by square root of 2 to simplify that. And we're looking for sine inverse of negative square root of 2 over 2. Now we're looking for where sine equals negative square root of 2 over 2, and that's going to occur at negative pi over 4. All right, today's lesson is the inverse of the tangent function. Inverse of the tangent function. Well, if you remember sine and cosine, we had to limit our domain in order for it to work. Let's go ahead and graph one cycle of our tangent function. Just a reminder that to graph a tangent function, we graph our vertical asymptotes at negative pi over 2 and pi over 2. We should have a point smack dab in the middle there, and we're going to go ahead and draw it like that. All right, the good thing about tangent is the one cycle that we have here passes the vertical and horizontal line test. So just one cycle of our tangent is good enough to restrict it to. So we're just going to restrict it from negative pi over 2 to pi over 2, which means our tan inverse is going to exist in the same place our sine inverse did, and that's going to be in quadrant 1 and 4. All right, the reciprocal, let's not go that far yet, but our tangent inverse function also has a graph. Well, if you remember, we're just going to flip our x and y values, so that means vertical asymptotes are going to turn to horizontal asymptotes. So since I have vertical asymptotes at negative pi over 2 and pi over 2, we're going to flip those and have horizontal at negative pi over 2 and pi over 2. We are going to have a point in the middle, and we're going to go up like this, kind of, and then we're going to come down like that. And that is our tan inverse graph. All right, as it says down below, hey, the inverse of tangent is noted as tan inverse or arctan, and is restricted to quadrants 1 and 4. All right, let's do some examples. So the tangent inverse of square root of 3, this is the stuff we needed to memorize. We needed to memorize the unit circle and all of the tangent values, particularly the ones in quadrant 1. So we're looking for the tan inverse of square root of 3. Well, square root of 3 occurs at pi over 3. Arctan of 1, remember that's the same thing as tan inverse of 1. Well, if we go to our unit circle, where is tangent equal to 1? Well, it's equal to 1 right at that pi over 4. All right, then moving right along, we're getting to arc cotangent, or the inverse of cotangent. Well, first of all, let's graph one cycle of our cotangent function. And that has a vertical asymptote at 0 and has a vertical asymptote at pi. Then kind of like tangent, it goes right through the middle, but unlike tangent, cotangent is going to go downhill instead of uphill. That is my regular cotangent graph. All right, that means we're going to restrict our domain to just one cycle. Well, one cycle looks like it occurs from 0 until pi. Well, that's the same place that cosine did. So our cotangent is going to exist in quadrant 1 and 2. That's actually problematic. We'll get to that in a second. All right, let's go ahead and graph our inverse of cotangent. We're going to change our vertical asymptotes to horizontal asymptotes. We still are in the middle, and we're still going to go downhill, so it's going to look something like that. All right, that is our cotangent inverse graph. All right, now here's the big problem about cotangent being in quadrants 1 and 2, and that is the fact that tangents in quadrant 1 and 4. The problem arises because we're going to use tan inverse to get our cotangent inverse numbers, just like we did with sine and cosine in respects to cosecant inverse and secant inverse. But tangent is going to actually put things in quadrant 4. So there is a possibility that we're going to be put in quadrant 4, and if we look at cotangent inverse, we can't be in quadrant 4. So that comes up with a whole list of things. So cotangent inverse is going to be the exact same thing as tan inverse of the reciprocal inside as long as our x is positive. If our x is negative, we need to add pi, and we'll talk about why in just a second. So that's any time our x is negative. If our x is pi over 2, or if our end result is pi over 2, that should actually say x. Let's change that. That should say x over 2. No, I'm sorry. That's right. It's going to equal pi over 2 whenever x equals 0. So if x equals 0, we're going to spit out pi over 2. And why do we put that? Is because tan inverse is actually undefined at 0. So cotangent is actually going to equal 0 at pi over 2. All right, let's do some examples. All right, our first one is cotangent inverse of negative 1 over square root of 3. So to rewrite that in terms of tangent, we need to take the reciprocal on the inside. So that's going to be tan inverse. That's going to be tan inverse of negative square root of 3 over 1, which is really just negative square root of 3. So what that would tell us to do is go to our unit circle. I'm not going to put equals yet. We're going to go to our unit circle, and we're going to figure out where tan inverse equals negative square root of 3. Well, tan inverse lives in quadrants, let me just erase that real quick. That lives in quadrants 1 and 4, so that's the only place I can look. Well, it equals negative square root of 3 right here, which would give us 5 pi over 4. Well, actually, since we're in tangent, we'd have to go in the negative direction, so that would actually be negative pi over 3. All right, but here's the problem. That's in quadrant 4. That's in quadrant 4. And if you look at your cotangent, it only exists in quadrants 1 and 2. So basically we can't use any of these quadrants. So to alleviate that problem in the fact that we are in quadrant 4 and we need to get back up to quadrant 2, is we're going to add pi to it so that we can shoot straight across and give that answer. In other words, where would tangent equal negative square root of 3 if it was allowed to be in quadrant 2? So our end answer is going to actually be, since it's less than 0, we're going to add pi to it. So it's actually going to be plus pi, which is going to give me negative pi over 3 plus pi. Well, let's change pi to being 3 pi over 3, which is going to equal 2 pi over 3. So basically what happened is we used tan inverse to find out that our point was down here, and we had add pi to shoot it back up there. That's why we add pi, to put in the quadrant that it could originally be in. Well, our next one is pretty easy. It's just arc cotangent of a positive. For positive, all we have to do is take tan inverse of the reciprocal, which would be 1 over square root of 3. I don't have to add pi because it is positive. It would be in quadrant 1. Both tangent inverse and cotangent inverse live in quadrant 1, so we don't have a problem there. We should multiply the top and bottom by square root of 3. which would give us tan inverse of square root of 3 over 3. Where does tangent equal square root of 3 over 3? Well, that equals it at pi over 6. All right, down below is just a little more information on our graphs, and put some notes on there about cosecant, sine, cotangent, and tangent. Just a place to put notes for you to study for the test. All right, good luck on the homework.